We're going to look at deseasonalising data now, but let's do a quick recap of what we've done. We've started with our raw data. So our raw data was this. Here's what we actually sold. This business for ski gear selling coats in the first and second and third year, and there's the 4 seasons that they measured their sales across. Then we figured out the seasonal indices, and that we said that in summer they were selling about the average, winter they were selling autumn they were selling above average, winter they were selling drastically above average, and spring they were selling drastically under average, which makes sense. In winter you expect to be selling more if you're selling winter gear. Straight after winter you'd expect to be selling less because you're advertising winter gear to people, so it's winter ski gear. So logically it makes sense, but we can actually see already in the trend that in autumn, over a period of time, their seasonal index is reducing, which means their amount is reducing regardless of the season. And here it's also reducing in winter, but in spring and summer, their seasonal indexes are increasing over a period of time, which is a good sign for a business. So they're increasing their average sales in spring and summer, and they're reducing their average sales over autumn and winter, which is bad news for autumn and winter. So maybe this business needs to look at their autumn and winter sales a bit more, whereas spring and summer are flying on quite a good business fashion. So we've got this raw data and we've found the seasonal index. What we're going to do now is we're going to kind of merge these two together. We're going to apply them together. So we're going to multiply everything in the table by the corresponding column. And that will tell us what would have happened if seasons didn't exist and the business sold exactly what they should have sold according to their business strategies, regardless of what the temperature was in terms of seasons, and the fact that it's coming up to snow season, so people want to buy snow gear, all those sorts of things. So we're going to be able to see how much in number of sales would the business have sold if seasons weren't a factor that should be factored into the business, which is really useful because it can help us to project trends and weaknesses in our business. So the deseasonalised data, we're taking the season out. The deseasonalised data is the actual data for the season, so that's, for instance, summer in year 1, 920, divided by the seasonal index, so summer in year 1, 1.00. And obviously anything divided by 1 is going to be the same, but we'll see that how we go. So deseasonalising data enables us to see the long-term trends in data without worrying about the fact that seasons are affecting our sales in our business. So we're going to fill out this table by doing some work on the next page. What we can expect to see is that our raw data would look like this with all these seasons in there. Once we've finished, it's going to look like this. So we can actually see that over a period of time we've got an increasing trend, we've increased our sales, and in this fourth quarter so that must have been spring in year 1, we've actually got drastically reduced sales on what we expected regardless, and we can actually see 0.48 is quite low here, spring of year 1, and then all the way up here, number 9, so that's number 9 there, that was 4. We can see we've got this peak here. Number 9 must have been summer, autumn, winter, spring, summer, autumn, winter, spring, summer of year 3. So summer of year 3, we sold 1.1, quite a bit more than we did in the other summers, quite a bit more than expected. So you can see we've got this peak in sales in summer in year 3. So we'd be asking ourselves as a business, what did we do in spring in year 1, which was bad? Or what were our strategies? They must have not worked. What did we do in summer of year 3? So that's summer year 3. What did we do in summer of year 3 that really peaked our sales? We must have run a promotion that was great, or we must have paid for heavier advertising or something like that. So let's look at actually deseasonalising this data now. So basically what we need to do is do the actual data for the season divided by the seasonal index. So let's do that. Let's go year 1 summer equals the actual data, so that was 920. You can see that over here. 920 was my actual data, and then divided by my seasonal index which was 1.00. I might do a sneaky and sort of put them back both on the same page. 920 over 1.00. And that equaled 920. So I'm going to put that in this box here, 920, which I hope you can see. Yep, you can see that. Let's do the next one. Let's do autumn of year 1. So that was 1085 divided by 1.18, and that'll be set for. I actually haven't calculated these values, I'm sorry. So I'll fill them in after the video's finished. I'll just do a quick summary video. The same process arises, whatever that is. Winter, so actual data for winter 1241 divided by 1.34. So we're doing winter year 1, that's this one here, and then winter year 1, that's this one here. Actual minus our seasonal index. And again, I'll figure that one out in a minute. And spring, which is 446, our actual data, divided by our seasonal index 0.48, and then again, I'll fill that out in a minute. So I've just continued that one down the page for you. Right, I might pause the video there. I'm going to quickly fill out all of them, and then we can finish off and round off our deseasonalising of our data.